Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello all, welcome to Vishwa Academy. Now we'll be discussing about the consistency topic about your concrete. So we'll be discussing about the compressive strength. So we'll be discussing about compressive strength. So if else we are discussing about any concrete like element, in general we'll be having a compressive strength with respect to FCK. So or else the characteristic strength of steel is described with respect to your particle ratio, such that it depends upon your mixed design for M20 or M25 or M30. So we'll be deciding the characteristic strength as 20 megapascals, 25 megapascals and 30 megapascals. So depending upon the variation, we'll be describing the characteristic strength. So in general, for the compressive strength, for that one, we are having 5000 under root FCK. And the tensile strength. So whenever we are going with respect to tensile strength, we are having the variation of, we are going with respect to compression strength. If we are going with the tensile strength, it is nothing but we are having a formation of 0.7 under root F. So in generally we'll be calling it as Fk. So what is that? Fk is nothing but we have a just formation of, we can conclude this one as Fk. So in general, if as for the point of gate or any competitive exam or any PSUs, we'll be having that compressive strength FCK will be greater than FST. Like if else we are going with respect to compressive strength, the compressive strength of the concrete is greater than the compressive strength of tensile, and that will be greater than your bulk modulus or shear modulus, anything. So this is what will be flowing with respect to this. If else you want any other circumstances manner, if you are going into generalized way, we are having compressive strength is greater than your nothing but a strength that is accumulated from the compression strength is greater than the tensile strength, and that is greater than your bulking modulus or flexural. If you are going with respect to flexural, you'll be finding out with respect to your strain, and that is greater than your tensile. So that is the format that will be generally prescribing. So this is what the format, comparing to the entire things, will be having compressive strength is greater than the tensile strength, then that will be greater than your bulk strain or flexibility. Strain can be given with respect to your flexibility, with respect to your shear. So that is the format that will be describing with respect to shear and flexible. So that is what general phenomenons that will be standing in a general competitive exams or any interview formats. So this is what we'll be discussing about the compressive strength. If you are going with respect to any other element, like if you are going into the second aspect like concrete and other steel like elements, will be having Fe. Like if in the format of concrete, we'll be discussing as FCK and Fi. So but whenever we are going with FCK, in terms of steel we'll be discussing about Fe and Fi. So that is what we'll be discussing in the next topic. So we'll be going to the next topic as we'll be discussing the next topic as your chapter 2 as steel. So before going to steel, what are the exact from where the steel has been extracted and how many types of steel, or else when we are going into steel or iron. So if you are going with respect to steel or iron, that is two are different formats. Then we are if we are going with respect to steel and iron, iron is a different component and steel. For casting of iron, then we can obtain a steel, but iron is an exact material that can be obtained from your land around nothing but we'll go with respect to individual. So in general, materials are divided. Steel as per the materials are sorry as per the materials are divided with respect to ferrous metal and non-ferrous metal. Non-ferrous metals. So in the termination of ferrous, we'll be discussing about what is exactly ferrous accumulations and what are the byproducts. Nothing but the first impact is nothing but we'll be finding out the iron. From the iron, we can formulate the further phenomena into pig iron. And the next one, from the further formulations or further addition of your silica or something, with respect to your will be silica and with respect to carbon content. If you are existing with respect to carbon content, then we can formulate cast iron. And the further formulations we can go with respect to wrong iron. And the further casting with respect to that will be going with respect to the steel. And the further classification with respect to in the steel will be having two different formations like carbon steel and the next one alloy steel. So these are the general phenomena that will be in casting. Iron will be going with respect to as per the iron is a raw material. We'll be discussing individual when we are going into individual topics. So this is what iron. From the iron we can extract pig iron. From the extraction of pig iron we'll be going with respect to here cast iron. Cast iron with respect to wrong iron to galvanized iron, and then we can further formulate with respect to there is another formation. It is nothing but galvanized galvanized iron or galvanized steel. You can usually call as galvanized iron, which are used in a bulk elements. So these are the general phenomena of your ferrous metal. So in general, the compositions of ferrous elements can be obtained with respect to this theory. Because coming to the next format or else next prediction, non-ferrous, best example here alumina or aluminium, sorry. Aluminium, and next bronze, next brass, copper, and the lastly we'll be going lead and etc. So these are the general composition with respect to here non-ferrous and a ferrous element. The in general we'll be calling as Fe2O3, the ferrous oxide consisting of ferrous, or iron ore consisting of hematite. Iron ore hematite. In that formation will be forming the ferrous modulus. So in general construction element, we are discussing about a topic steel and iron. So we'll be entirely concentrating on iron, pig iron, what is exactly fermentation of pig iron and where it is used, and cast iron, how much of carbon contained and what is the amount of silica that has to be added to it. And then we'll be going with the wrong iron, and then we'll be going with the finalized with respect to galvanized iron, and then we'll be going to the steel. In that steel we will usually seeing with respect to construction element steel as well as stainless steel. So one is a carbon consistency steel and the next one is nothing but alloy steel. Depending upon where to use and what to use will be individually discussing about. Apart from the ferrous elements, we are having a non-ferrous element, nothing but in general alumina or else aluminum plates, whatever we are seeing, which is not exaggeration of your ferrous element. So in that we will be firstly few in general accumulations or general materials that are available, it's nothing but non-ferrous. First will be striking out with respect to your alumina, the second will be striking out with the copper, and the third, or generally in our day-to-day life, we'll be using a brass as well as bronze, and then we'll be going with respect to lead. The other materials are also called, generally there are number of elements with respect, apart from that, but as per a topic, as per the interest of topic, we'll be going with this. So this is what we'll be dealing about ferrous and non-ferrous. Then coming to the individual, we'll discuss what is exactly an iron and where is it has been extracted and what is the importance of the iron. And then going to the individual component. Then we'll be going individually. If you are going individual, the products of your iron and how the steel is formed and what are the different types of steel that is used. So coming to your iron. Iron is extracted from your iron ores, hematites. So in generally we will be calling as Fe2O3. That is a raw format of your iron that consisting of no carbon contents. Without any carbon contents, will directly ferment with respect to this. So once it is mixing with so iron is extracted directly. It is fermented with respect to oxygenated compound like air and water. So that is fermentation. Iron or hematite is communing with respect to air and water, and it is a byproduct. So like the accumulation, the output that we are seeing is nothing but iron. So that is what a brief description. But coming to your worldwide, as per the gate point of view, or else any PSU format of view, we are having, it is founded as sixth world element. Is founded as sixth world element. In general, we can they might be asking, or there might be a choice that it might be asked. So iron is the general substance of sixth world element. It is embarrassed as sixth world element. So we have to somewhat concentrated with respect to this deal. So coming to the next format of how the next fermentation, if the iron is melted, if iron is melted with 3.5, melted and add with 3.5 to 4.5 percentage of carbon, then we are accumulating a pig iron. This is a form output of your pig iron, and where it is used and what type of elements that are generally used with respect to this is nothing but we are fermented with respect to your replicas. Nothing but a pig iron is composition with respect to 3.5, a 3.5 to 4.5 of amount of carbon that is used with respect to this. So this iron is generally used with respect to your segmental substances. These are used for segmental substances or material with respect to allowable substances. So this is what we'll be fermenting with respect to this. So if iron is melted and added with respect to your 3.5 to 4 percentage of your carbon, then we are obtaining, we'll keep it as output so that it will be easier. So we can, that is what we can see. The iron is melted with respect to certain melted and added with the certain composition of your carbon. Then the output is pig iron. That is mostly used with respect to your segmental substances. Then the further after, if it is used with respect to when iron hematite, like whenever iron is melted and added with respect to your 3 to 3.5 to 4 percentage of carbon and 2 to 3 percentage of silica, sorry, it is 2 to 5 percentage, 2 to 5 percentage of silica is added. So whenever we are going with respect to 3.5 to 4 percentage of carbon and 2.5 2 to 2.5, sorry, 2 to 5% of silica is added, then the output we are seeing as cast iron. That is what the famous that we are generally using for here. What type of elements? Like we can see a manholes uses. We are seeing with respect to broadbands and manholes and covering plates, cover plates, etc. So these are the uses in general with respect to cast iron. Other than this, we can see with respect to fermentation terms and other things. So these are the general process that we are seeing with respect to cast iron. So coming to the individual terminations, sir, when we are going with respect to individual terms, cast iron is a mainly element that it is used with a high composition of the carbon, and a point percentage, 2 to 5 percentage of silica, such that the major complications with respect to your silica. So in that process, we are using a termination, like we are obtaining a cast iron phenomenon. So where the cast iron exactly we can choose a broadbands and with respect to manholes and cover plates. In general, if we are going with respect to your sewer pipes and other things, we are having a manholes which is casted with respect to, it has a dense what the other use of this one, we are having a high strength. High strength is usually required. That's what we are transferred. The manholes are capable, and that on that we are transferring with respect to our loads and vehicles and other things. So if the most important of the cast iron is nothing but we are using with respect to high strength the board banding elements like manholes and other things. So this is the consistency of this. On the further composition of that one, we are having, we can take the adaptability as we can conclude that the iron is commented with respect to pig iron, cast iron, and next we are going with respect to wrong iron. So exactly what it is nothing but it doesn't consist of not more than, it consists of not more than, sorry, it is only consisting of 0.2 percentage of carbon. So that is what are mainly wrong iron is used. The composition, it is added with respect to 0.2 percentage of the carbon with respect to iron. So that is what the high product byproduct of your iron we are making as a wrong iron. And where it is used are with respect to your pipes, your sewers, sewer drains, and your welding elements. Welding and any decorative purpose for your windows or doors. So this is what we are using with respect to wrong iron, and the major consistency with respect to this is nothing but we are using a wrong iron in a different way. It is also used with respect to your uh, what we generally called as your fall ceiling for floors and roofs. These are the fermented is used with respect to wrong iron. So when we are going with respect to elemental type of use, so iron is a fermentation with respect to your air and water that is accumulated with respect to this natural phenomenon which is formed with respect to iron ore hematites that is formed with respect to your air and water, and it is forming a capable iron. So iron is generally described as adhesive product. So it is a sixth world element. It is also called as adhesive product. Adhesive element or product. So iron is generally concluded as sixth world element or sixth world adhesive product. In that accumulations, if iron is taken and it is melted and somewhat a composition of the carbon has been added such that the flexibility, we cannot directly use an iron as an elemental format. So for that we are adding some composition with respect to your carbon consistency. So it is nothing but a pig iron has a huge carbon consistency. That is what we are making with respect. The output by adding carbon, the output is nothing but we are making a pig iron. It is used as segmental aspects of substance which can be used in a substantial formattings. So further consistency, if you are going with respect to iron is mixed with respect to 3.5% of 3.5 to 2 percentage of carbon with respect to addition purpose of silica, that is making an adaptability of your cast iron, where we can generally use with respect to high strength elements like broad banding and manholes and your cover plates. When we are going with a certain strength should be added to that, so we are going in this aspect. So further consistency, if you are going with the accumulations and further entity that can be used with this wrong iron, where we are using a less proportion of your carbon, that is not greater than 0.2 percentage carbon. That iron is used as a pipelining or sewage drains or welding or with respect to your windows and doors. It is not only for that, we are using for the floors and roofs also, for binding elements or else in a vastic elements, such that these are the probability of your iron. Then after this we'll be going for the galvanized, as well as what are the different types of steels. So we'll be going with a further accumulations like a galvanized iron. So further byproduct of this one, we are going with respect to galvanized iron. So what is generally we are calling it galvanized iron is nothing but we are accumulating with respect to a coat for non-rusting element. So what we are doing is nothing but iron we are mixing with carbon plus zinc. So that is what we are making a coat prevention, such that a zinc acts as a preventional coat. Zinc acts as preventional coat for rust. So as we see before the terminations before a pig iron, a cast iron or wrong iron, it can be easily fermented with respect to your rust formation, such that a depletion of the elements can be accumulated. But here we are providing a iron with carbon that is penetrated, that is cast with respect to your uh, zinc coat, nothing but it is called as galvanized coat. So iron is directly penetrated to galvanized. It's nothing but a protection layer, galvanized coat. So that is what we are making with respect at this with the help of zinc. So iron, we are making an iron with a coating of galvanized that is directly inserted in the your zinc paint, and that acts as a galvanized coat with respect to zinc. So that is what we are making with respect to addition. For example, if you are going with respect to examples, we can see a bar element which is colored in a fermentation, nothing but a zinc like element. We can see a silver color or a silver color coating will be adoptable. Iron bar which is coated with a silver color such that it is fermented. The best examples you can see with respect to all the railway stations or metro bridges which are constructed with steel bars or compound elements which are connected with, all are galvanized iron such that it is making a layer of protection with respect to rust, and this can be elected with respect to number of different components, such as going to box like element or C channels or plug channels or any. There are number of invarious elements, but in generally when we are coating with a zinc element such that rust is not adoptable. So to preventing from the rust, so such that there is no further depletion of the elements. If once we are not caring anything, if we are not protecting, that can be exposed to the moisture, that is like as we have replicated with respect to hematite, with respect to iron, with respect to air and water. So air and water is a general transmissions of your moisture content. Once those are accumulated with respect to your material, it starts depletion. As you can generally see with respect to your terrace, on your terrace, if you are leaving your iron bars which is coming from your floor, we can when we are catching that, we can easily see that there is a small brown color element, that is nothing but a rust, which is starting its depletion of the element. If you are leaving for the further replication, it retain its strength. To envelop its strength or else to fermentation the strength, we are protecting with a coat called as galvanized, nothing but a zinc coat we are adopting, such that it can act as a preventing element as well as your coating element. Then after galvanized, we'll be discussing about a steel and what type of steels that are present. In general, we'll be calling it as zinc paint. So coming to the next aspect of that, we have to discuss the main topic as a steel. So we are having the main element, like the next element is nothing but we are discussing about a steel. So in general, a steel is a product of iron mixing with carbon, but it should not be greater than 2%. Only 2% of the carbon that is adoptable or acceptable. So we are not concentrating on the aspects of interior chemical reaction, but in general we are going with iron mixing with a carbon of not more than 2%. Then we are calling it as steel component, nothing but we are generally classifying those are types of steel. If you are going with the types of steel, so we are having a generally format of two types. One is carbon steel, and the next one we are going with alloy steel. Nothing but if you are going in general, in detail about the carbon steel, the materials which are allocated only with respect to carbon, or else the particles which are associated with carbon is nothing but carbon steel. When we are going with alloy steel, these are further classified into three types. One is your stainless steel, next one high steel, high steel and low alloy. It is generally preferred as HSLA, and the next one will be going with respect to less alloy or low alloy steel, and high alloy steel. So these are fermented into one classification. So in general, if you are going, a steel is fermentation with respect to iron with mixing of a carbon contingents. So that carbon, it should not be more than 2%. So coming to the aspects of steel, how many types of steel that we are having is nothing but a carbon steel and your alloy steel. And alloy steel is further classified into a stainless steel, high steel with low alloy, and low alloy steels and high alloy steels. Depending upon the modulability, depending upon the sources that we are saturating the elements, where to use and what to use is nothing but this is what will be fermenting with respect to your types of steels. So coming to in detail about what is exactly a steel and what is exactly a carbon steel consisting of. So if you are going with respect to the first type of steel, nothing but we are having carbon steel. We'll completely discuss this, then we'll go into the alloy steels and what type of alloy steels are present and what is the accumulation of the steels that we can generally saturate it in our regular construction element. So exactly, a carbon steel is nothing but high amount of steel high amount of steel or iron mixed with the carbon. So output, we can generally see what is the output. Nothing but in general we can see a fermentation of different types of steel. Generally we can called as bar steel or bar iron. Next, complex ions or sectional steel. Sectional steel or complex steel. And the third one will go with respect to Vatic steel, nothing but in general will be called as angular steels. The last one we are calling as plate or sectional. In these four different types we can see the output. A carbon, that is mixed with, like a steel mixed with with respect to your carbon, and the output we are seeing as a bar steel. Where the bar steels in generally we are using in the construction format. In the construction with respect to, especially with RCC. Especially with respect to the RCC is nothing but reinforced concrete structures. We are using with respect to RCC, or RCC structures are almost with respect to bars. So what is that bar type element that we are seeing in generally? A bar diameter of minimum 6 mm to accumulation. In general we are using with respect to 64 mm. There is more than that required element also, but in generally available market elements, like when we are going in detail about a bars present in the market is nothing but in general it is nothing but 8 mm, sorry 6 mm, 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, coming to 22 mm, 25 mm, 28 mm, 32 mm. Next we have 44 mm, sorry 48 mm and 64 mm. So in class there are number of bars, but in general markets will be using as 6 mm bars, 8 mm bars, 10 mm bars, like similarly 12, 16, 20, 22, 25, 28, 32, 48 and 64. These are the general bars that are available in the market sources, but usually in the construction practice, uh, 6 bar is play majorly role as your mild steel or your stirrup bar, but it is no longer, it is placing as a mild steel, nothing but ms bar will call as ms bar, but or else stirrup steel bar. But presently not available in market. Beforely in a previously we are habituated to 4 bars also, but usually our bar element starts with 6 so 6 bars are minimum diameter of a bar as per the point of your interview or else PSU or the aspects of gate. In 2012 sorry 2002 they have asked the question like what is the minimum size of a bar that are used in a reinforced RCC construction. Nothing but there are the options that A bit as 6 B bit as 8 C bit as 10 and D bit is none of the above. So most of them has been preferred for none of the above, and some of them preferred with respect to 8 because they are presently used with respect to 8 bars, but previously they are habituated with 6 bars, even though it is not available in the market. But we are the minimum diameter that we have to use. Minimum bar is nothing but 6 bar that we have to use. So answer is here 6 bar. So insaturately, when you are going with respect to this, the minimum size of a bar is nothing but 6 So I'm writing it out. So make sure that the minimum size of bar is 6 and if you are going in detail about individual, we'll be discussing about individual. Minimum size of bar in beams and columns is nothing but 12 and in slabs it should be 10 So these are the basic requirement that we have to remember. So minimum size that we are using in the construction practice is nothing but a 6 but when we are going with respect to regular practice sources, the minimum bar size that we have to adopt with respect to beam and column is 12 and the slab minimum size should start with respect to 10 such that the adoptions will be in a categorization load pattern will be in a equalized. If you are not properly using less than that, there might be a load deviation and spacing might be different depending upon the sources. So coming to the next aspect, so just note it down, then we'll go into the next pattern. So coming to the next pattern about next type of steel. In the regular phenomenons, we are going with the sectional steel. So coming to the pattern of sectional steel. So what is exactly a sectional steel is nothing but so when we are going internally about a sectional steel, If you are going in the practice of steel construction, we can see a type of steels, nothing but we can see a box or hollow section or rectangular section, rectangular bars or bar. Next, C shape or channel shape or else angle shape. Further coming into here, any T or L shape. So these are coming into sectional type of complex. So whenever we are going into angular, so whenever individually if you are going with respect to individual aspects, the structural frame, if you are going with respect to construction of any element like a box frame like element which is distributing, or else if you are going with respect to your regular steel structure which is constructed beside your house or something, we can see like now there are number of components. For a best example component, if you are seeing as a car shed, there are poles which are accumulated with respect to your plastic frame. So in that element we can see either in a rectangular or circle uh, rods which are available with respect to the hollow. The entire the cross section, when we are going with the circumference there will be a steel, but when we are going into it internally it is nothing but a hollow. So in that aspect the hollow sections are available with respect to this. It can be acceptable with respect to this also. So this is a material that is available with respect to here. So in general, hollow is available in that way, shape or any other shape depending upon your source or load that which is considering with respect to applications. So in general, in a quiet way or in general way, we can see that hollow sections are preferred with respect to rectangular and circular. Other than this, it is nothing but a square. So come with respect to it might be in a hexagonal shape and it might be depend, so depends upon the source or depending on the customization these are available. So coming to the rectangular bar, so in general rectangular solid element rectangular solid element for if you are going into the mass construction, we can in the place of bars we are using exactly a rod shape element or else rectangular bars that are fixed with respect to your tune, or if you are going with respect to plates, the rectangular plates is also accumulated with respect to this. So these are also called as plate with respect to your welding or rivet construction, welding or rivet construction or any type of bolting. You can also go for bolt. So these are generally proposed with respect to rectangular shapes or which is casted. But if else we are going with respect in RTC versus like a regular format that are fixed with respect to other format. So in that formation, a rectangular bars, a strip-like element that is saturated and that are used with respect to plates like a segmental also. So when you are going with respect to your channel sections, so what type of channel sections we are available with respect to this? So in general, we are having a channels as C shape, C shape channels or double C shape, or when we are going with respect to any other channels, if you are going with this one as your incubation, so this is solidified. So these are solidified. Other than that, there might be elements with respect to here. Like if you are going into further classification, we can see a box-like element. So these are nothing but angulars. If you are going with respect to angle sections, these are the best example with respect to the angles. So angles are the best example with respect to this. And if you are going with respect to any other like L and T shapes, these are the L shapes, or these are the other angles. And if you are going with respect to the angle sections, we are having I or H shape, depending upon the I, or depending upon the H, depending upon the sources that is available. So it might be tuned with respect to here, it might be tuned in this way. So these are the general section properties that are available in and around the sources. So practical practice of steel construction. So what type of sectional steel that are available? If you are going with the individual one, if you are going with individual one, the hollow sections, if you are generally where it is available, hollow sections we can see in all the construction where the load is generally lesser than the fricted element. So in general practice, we'll be adopting for the saving of material or saving. If we are going in economical aspects, we'll be allocating with respect to your hollow sections mostly preferable. So if the as per the load, we can arrange the either with respect to circumference or with respect to the area that is fermented. And the next type we are going with respect to angular section, which is connected with either in a solid section of rectangular or channel or angle or LN. Depending upon the load conditions, we are arranged to fermented whether the load is coming from the structure. If else we are having, for example, a bar which is consisting of a, we are constructing a bar with respect to solid element. It is completely solid. The other one, it is constructed with hollow solid. So providing depends upon the provisions, which if it is completely solid, it can bear up to a load. It is also replicated in the same load with certain upliftments. Either we can use a solid with respect to your angular sections where it is used. Depending upon the load that can be capable, we can predict the load where it is acting exactly and what type of the load that is coming exactly, and then we can ferment it that load if the load is coming to that area and what type of cross section that we have to adopt. So depending upon the load adoption or general practice of construction, we can arrange the hollow section and we can save as per the economical point of view. So in general, composite in the practice of sectional steel, majorly hollow sections and the angular sections are mostly used, because if you are going an example of your current pole, if you are going into the examples of current pole, if I am going with respect to the examples of your current pole, we will be discussing the examples so that it will be clear. So example, if you are going with respect to current electrical pole, if you are, we are going with respect to cross section, if you are going with the cross section, it will be somewhat in this way. And if you are going with exactly in with respect to altitude, it will be in this way. It is exaggerated in this way. So it is exactly when you are going with respect to cross section, there will be a tunal positions. So this is what we can arrange internally So that is what we can see. So that a cross section, as per when we are replicating the cross section, the material as per the economical, it is somewhat easier. So hollow sections in the parking shed. Next example, if you are going with parking shed. So we can go with this until with respect to solid, we can go with respect to bars that are encasted. So this is a terrain that is applicable. So these are the regular phenomena, regular practice with respect to cross section. Thank you. Then we'll be thank you. Then the next sections will be discussing in the next class or next session, depending of